So welcome. So today I'll discuss about SSB, single sideband modulation. So in single sideband only one sideband is transmitted. Okay, in double sideband we suppress the carrier and two sidebands are transmitting, but in single sideband only one sideband is transmitting. The remaining sideband we suppress. That's about single sideband modulation. So in SSB, this is the general equation. S of t is equal to Vc Vm by 2 cos 2 pi Fc plus Fm into t. Vc Vm by 2 cos 2 pi Fc minus Fm into t. This is upper sideband, this is lower sideband. See, only one sideband is transmitting in SSB. That's why it have the name. Its name is single sideband transmission. So this plus time for upper sideband and minus time for lower sideband. So this is upper sideband and this one is lower sideband. Only one sideband is transmitting. So this is the general equation for a single tone modulation. Vc Vm by 2 cos 2 pi Fc plus or minus Fm into t. Okay. Single tone modulation means only one frequency. Vc Vm by 2 cos 2 pi Fc plus or minus Fm into t. In this, plus for upper sideband, minus for lower sideband. Okay. This is the general equation. So we know that cos of a plus b is cos of a plus or minus b is cos a cos b minus or plus sin a sin b. So similarly, Vc Vm by 2, this equation we can modify. Vc Vm by 2 cos 2 pi Fm into cos 2 pi Fc into t minus or plus Vc Vm by 2 sin 2 pi Fm into sin 2 pi Fc into t. Okay, so based on this equation, so we know that m of t is Vm cos 2 pi Fm m t. See, m of t, what is the message? Vm cos 2 pi Fm t. Vm is the amplitude, this is the sinusoidal wave. It's a cosinusoidal wave. So Vm cos 2 pi Fm t is the message signal m of t, and Vm sin 2 pi Fm into t we call it as m cap of t. See, this is cos, then this is sin. What is the difference? This is cos, this is sin. So we call it as m cap of t. M cap of t we call it as Hilbert transform of m of t. Okay, Hilbert transform of m of t. Hilbert transform means this transform produces 90-degree phase shift. That is what is called a Hilbert transform. That means, listen, Hilbert transform produces a 90-degree phase shift. That is m of t. Taking Hilbert transform of m of t, you will get m cap of t. That means cos means it will reach a sin in Hilbert transform. So that's why it is written like this. This is Vm cos 2 pi Fm t and Vm sin 2 pi Fm t. So if we choose Vm cos 2 pi Fm into t as m of t, then Vm sin 2 pi Fm into t is taken as m cap of t. So how to rewrite this equation? AC by 2 m of t cos 2 pi Fc t minus or plus AC by 2 m cap of t sin 2 pi Fm into Fc into t. So this is the time domain equation of SSB multitone modulation, and here minus for upper sideband, plus for lower sideband. Okay. Now this is the power calculation equation for SSB. So we know that total power transmitted is either upper sideband or lower sideband. Why? Why? Because here we are transmitting only one sideband. So we need to consider only one sideband, no? So total transmitted power is nothing but upper sideband or lower sideband. So what is P upper sideband, the power of upper sideband? We know that P upper sideband is Vrms square by R. What is Vrms? Vm by root 2. What is Vm here? What is the maximum voltage here? What is the maximum voltage here? Vc Vm by 2. Okay. So Vc, instead of Vm we can put Vc Vm by 2 by root 2. That means Vc Vm by 2 root 2, the whole square, by R. you rearrange this, you will get Vc square Vn square by 8R. So Pt is Vc square Vn square by 8R. This is the spectrum of the transmitted signal, or this is spectrum of SSB. See, listen here, this is shifted here and here, but only one sideband is transmitting. See here, this is the upper, so upper side is transmitting in this system SSB. So this is the spectrum, only one sideband is transmitting. So the thing is, what is the bandwidth here? In double sideband we have bandwidth 2 times FM or 2 FM. But here what is the bandwidth? The upper frequency minus lower cutoff frequency. That means FC plus FM, FC plus FM minus FC cancel out, you will get bandwidth equal to FM. See, bandwidth is FM. In double sideband suppressed area bandwidth is 2 FM. In SSB we have FM. That means bandwidth is reduced there. That is the advantage here. Why we need to choose SSB? Why? Because we can reduce the bandwidth, also the transmitted power also we can reduce. Only one sideband we need to transmit, okay, no? In DSP we need to transmit 2 sideband, but in SSB only one sideband is transmitting. So transmitted power we can save. Also bandwidth also reduces. Signal bandwidth is reducing. What is the efficiency here? Eta equal to P upper sideband by total power. What is P sideband? P sideband means only upper sideband we are transmitting, so P upper sideband by total power. So P upper sideband by P upper sideband, which is nothing but 100% efficiency. And that's about SSB modulation. And the next is switching modulator. I will discuss in next class.